Okay, today I want to show you how this product, Coherence, Oracle Coherence, is awesome. And to do that, I started from a use case that I had with 3 customers this year. And I will show you what happens if you had coherence in this kind of use case, and so in this kind of architecture. So as you see, you have a community edition of Coherence, and sure, you have an enterprise version of Coherence that is supported by Oracle. You can choose the one that you need. Personally, I did this kind of small test, small POC with Coherence Community Edition. Okay? I started from this use case. This use case is a customer that have IoT sensors sending metrics from clean room to an autonomous ATP. Okay? And as IoT sensors are sending metrics one by one every 1 second, okay, on the architecture, we used OCI ORDS managed. So this is the ORDS managed by the autonomous service in order to insert JSON with all the metrics of the clean room sending by the IoT sensors. Okay. One by one, every 1 second, one IoT sensor send a list of metrics. So doing that, okay, I use K6 on this architecture in order to do a load test with 100 virtual users. That means 100 IoT sensors. You can see here that I have an ATP, okay, my ATP 23 Hz with only 2 eCPU. So this is the smallest one ATP that we can have with only 2 eCPU. It means only 2 threads, okay? During the load, with 100 IoT sensor sending metrics, and I choose to not send metrics every 1 second, but every 0.5 second, okay? Just to double the load in order to be sure that it will be okay for the customer later. You can see during 30 minutes, so I got the average answer for inserting the JSON with all the metrics, and the average time is 34 milliseconds, and the percentile 95 is 48 milliseconds. Okay, during 30 minutes, I inserted more than 300,000 metrics. Okay. Then, looking at the autonomous DB, okay, because you have all what you want here. You can have show the monitoring part with the CPU and so on, and you can click on the performance hub in order to have other CPU. So just to have a look at that, okay, I see 80% for the CPU of the ATP. 100 IoT sensor waiting 0.5 seconds before each request. Okay, and as you can see, concerning the CPU usage on the performance hub on OCI cloud interface, you can see that I am at the maximum usage without wait. Wait, it means I am over the maximum usage, and then I have some threads from ORDS that are waiting the DB. You can see here, it's perfect, okay? It's perfect, but I am at 80% CPU usage. So I cannot go over that. I can go over that and I will have so the auto scaling and so on that could happen, but I will pay more than to a CPU. Now imagine I just want to use an architecture, and on this architecture I will use this one. Okay, this one, it means I put between IoT sensor or mobile application and ATP, I put Oracle Coherence and in-memory data grid as a middle layer. Okay, and you will see what is the result of doing that. It's incredible because Coherence is really the best in-memory data grid of the world. The scalability is incredible because I will continue to insert JSON metrics one by one in Coherence. Coherence is an in-memory data grid, so the insert is only in memory, and this is a distributed architecture. But using a feature of Coherence that we call write behind, I will have asynchronous insert in autonomous. Okay, but doing the asynchronous insert, I will do JDBC with bulk insert. So instead of inserting one JSON payload one by one, I can insert several JSON payload at the same time. 100, 200, 500, 1000. Okay, it will depend. Okay, and you will see what is the result of doing that. Exactly with the same load, 100 IoT sensor, waiting 0.5 seconds before each request. You see, okay, then average time is 14 milliseconds. Imagine it's like IoT sensor on my laptop and the ATP is on Oracle Cloud. Okay, and the percentile 95 is 21 milliseconds. Okay, and more than again 300,000 insert during the load. Looking at the DB, okay, you can see near very small CPU usage due to bulk insert. Okay, very, very small. There is no load regarding the usage of ATP. It's okay. Okay, and so just to describe this architecture, and in order that you understand this result, it means, okay, it means ATP is cool. Okay, so I don't need more eCPU on ATP. Okay, just to describe here the architecture and just to show you clear, I want to show you here the pods. So I have a Kubernetes cluster with 3 node pool, so it means 3 VM. And on this Kubernetes cluster, I deploy the Coherence grid, in-memory data grid, with 3 storage nodes and 1 Spring Boot with a REST service in order to insert data in Coherence. So very simple architecture. Okay. Doing that, you need to imagine what happens. First, concerning Coherence, as a developer, I have developed a class, a cache store, where I have implemented some methods, and the main methods that is important in this POC is store all. It means Coherence is taken one by one transaction, one by one, but at the end called this method store all in order to store data in the ATP, okay, using just JDBC, okay. And so as you see at batch, it is a batch bulk insert. So very, very fast using JDBC compared to an insert with ORDS one by one, okay. Just looking at that, you can see here, looking at the dashboard Grafana interfaces for Coherence, that generally here, Coherence did batch size insert near 300. So instead of doing insert one by one, Coherence is doing insert 300 by 300. Okay. And you know what? Oracle DB loves that. Oracle DB loves bulk insert, only one commit. And Oracle DB hates one insert, one commit, one insert, one commit. And you can see that here. Okay. Now, I decided to do another test, and with 100 IoT, waiting only 0.1 second between each request. It means the number of requests comparing to the previous test is multiplied by 5. Okay? You can see average insert 13 milliseconds. Again, IoT sensor like on my laptop and ATP on the cloud. Percentile 95 is 18 milliseconds. Okay? During 30 minutes, this time I inserted 1,600,000 JSON payload with metrics. So, as you see, super fast. Look at the DB. The DB, nothing. Super small CPU due to bulk insert from Coherence. And as you see, it's okay. I can do more. I can do more. And regarding the storage node, this time, Coherence is inserted data using a batch size, an average batch size insert of more than 1,000 payload. So it means a group of 1,000 payloads to insert in ATP, in one time. 1,000 payload, only one commit. And it's super, super, super fast. Okay? So, what we can imagine on this kind of architecture is that we are able, with this kind of architecture, we are able to implement use case with a lot of IoT sensor, a lot of mobile application, just doing real-time insert in Oracle Coherence. And after that, Coherence will do very big insert in ATP, and ATP is cool. No need a lot of eCPU, and so you pay less. Another point that is super important is I can stop ATP, okay, during a time t. And during this time, I will have zero error regarding the architecture. And I want to show you that, okay? I have my ATP that is here, information, and I am going to run the bench. So for example, select count. Okay, start from sensor 3. Okay, look at how many JSON I have in my collection sensor tree in ATP. Okay, you see 2,900,000, hey, 2. Okay, and now I can go and launch the insert with Coherence. Okay, so I'm going to do the load test, and it's okay. Okay, I'm doing the load test. For this load test, I used to sleep only 0.5 seconds, okay, because just to show you how it's possible to have a super nice architecture without the DB during a time t, okay. And just to check here, okay, 8K2, just to see if we have insert. Okay, 373, so we have insert. Now, just to have a look to the log of Coherence storage, as you can see, we have here insert asynchronous. It means sometimes a big group of JSON is inserted from Coherence, and the insert is super fast, from Coherence, okay, that is near ATP in the cloud. Okay. Now I'm going to stop the autonomous. So stop the autonomous. Okay, let's stop. So the autonomous is going to stop. Okay, just we are waiting, stopping, just to refresh. Okay, and stopping. Okay, just have a look on the logs. As you see, error, because in the JDBC code, it's trying to insert data in autonomous, but autonomous is out. Looking at the bench, you have 0 error. You know why? Because I insert data in Coherence, and it's okay. And then Coherence try to insert data in ATP, and Coherence got errors due to ATP is not here. But I can just start again, ATP. And the default behavior of Coherence is super nice, because each time you have an error in the code, then Coherence decided to rerun the insert later. Okay. So just during a time t, I can wait. Sure, you cannot wait 2 days or something, because you put data in memory. And you know what? I put a time duration in Coherence of only 15 minutes, but I can put 1 hour, 2 hours, 3 hours. Okay. After this time, data will disappear. Okay. But here, ATP is available. Again, just have a look to the storage node 1, and you see, oh my God, Coherence is inserting data in ATP. I got 0 error. If I stop here the bench, okay, if I try to stop here the bench, okay, I see 0 error. Okay, 0 error. It means I insert all the data in Coherence, and Coherence is a distributed architecture, so I use 3 nodes, but I can have 5 nodes, 10 nodes, 20 nodes. It's quite incredible. And I have backup. I'm doing an insert. If I lost a node, I have backup, so I will not lose data. And at the end, it will go to ATP. So this architecture is a super nice architecture. You have an incredible scalability due to Coherence. You can work during a time t without the DB. So it's very, very nice. Okay. And the performance is quite incredible too. And you know what? Coherence has a lot of feature more than that. Now, to monitor that, we have a lot of Grafana dashboard in order to have a look to Coherence here. As you see, all the dashboard are done for you. You have just to install a Prometheus and to declare on the different nodes the metrics, and then you will have that. It's super, super nice. Remember, I use OK, and I use the Coherence Operator to deploy Coherence in OK, a Coherence Community Edition. Okay. So remember, this architecture is the most incredible architecture with a very, very nice product that is Coherence here. Thank you for your attention.